And with our study of quadratic forms, now we're going to categorize them. And this is really what the bulk of that page 267 in 4.2 discusses. So we talk about a quadratic form being either positive definite, positive semi-definite, negative definite, negative semi-definite, or indefinite. Okay? And so mathematically, the property that a positive definite quadratic form has is that, let's go back up, is that we have the polynomial is greater than 0 for all x not the 0 vector. Okay, and a classic example of this might be something like x squared plus y squared. Okay, so our basic paraboloid. So we have the paraboloid, and you know I'm the world's best artist. Okay, so we would have the function being 0 at the 0 vector, but we're saying that otherwise the polynomial is positive. Any value of the, or I guess it would be strictly above the 0 vector. Okay. For positive semi-definite, that's where things get a little wishy-washy, in that now we're saying that it can be not just greater than 0, but greater than or equal to. Okay. And simultaneously, it cannot be positive definite, and I'm abbreviating positive definite. Okay, an example of this might be something like x squared. So we have that basic parabola, right? But we extend it forever. Yeah, we extend it forever in the y direction. And so it would look something like this. And I just need to make sure it looks like a parabola at the end. Something like that. Okay. All right. So here we would be at 0, but then I have 0 along that entire axis there. Okay, so that's an example of positive semi-definite. For negative definite, this one is where instead of it being greater than 0, guess what? It's less than 0. Okay, for all x, not the 0 vector. Okay, so this might just be the opposite of that paraboloid that we discussed at the beginning. Oop, not plus, minus. So slap a negative sign in front of everything. Okay, and so we're going to get that paraboloid opening down. And the only point that would be at 0 is that maximum point. Okay, and then for semi-definite, we would again have the same idea, that we would say it's less than or equal to 0 and cannot be negative definite. Okay, so again, take our example from semi-definite and slap a negative sign in front of it. So we have a parabola and we extend it in the y direction. Something like that. Okay. And then indefinite actually occurs more often than you think. But the formal definition would be that there exist vectors x1 and x2. That's a 2. that are not the zero vector such that P1 of x1 is greater than 0 and P2 or P of x2 is less than 0. So we have a little bit of positive and negative stuff going on. And so what we might see here is something like a saddle. Okay, so like if we do x squared minus y squared. Okay, so we're going to have a little bit of that parabola shape going on for the saddle. And then so that would be kind of where it's positive definite, and then we would have the negative definite going down on each side. Okay, and so if we look at the origin, it would be right there. Okay, so we see that there's a little bit of curvature up and a little bit of curvature down. Okay, so that's the idea with all the definiteness. And just to get some quick examples in here, we should have that if we look at the first one and we think of all the values that are not 0, those are always going to be positive because we're summing squares. So this one should be positive definite. Okay. The next two, I actually want you to take some time and pause the video and see what you get. Alright, well, you might have said that the second one is positive definite, only because, well, we have a square here, and we have a square here, and so that's always going to be positive. And then, well, what about this middle thing? Not quite sure. But what I could do is I could recognize that this is x plus y quantity squared. And this, okay, so it could be always positive, right? But what about along the line where y is equal to negative x? Isn't it 0 there? So then this is always going to be greater than or equal to 0, so this is positive semi-definite and not not p. So positive semi-definite is what I am using this for. Okay. And then for the second one, I believe here that this one could be challenging to determine exactly, but if you happen to look at r of 1, 0, 0, that is going to be negative 6, and r of 0, 0, 1 is going to be positive 4. So we do find values that are both greater than 0 and less than 0, so this is going to be indefinite. Okay. In the last case here, okay, you might automatically think negative definite, but again, maybe just take a moment to think about this and try some factoring. If you factor out a negative sign, what you're going to be left with is 2x plus y quantity squared. So I kind of employed that same trick that we did above. And so this is always going to be less than or equal to 0. So this is going to be negative semi-definite. Okay, so sometimes algebra is going to help. Other times algebra could be annoying, as in this case, right? Other times you might not be able to tell from the algebraic representation alone. So what do we do in that case? Well, we'll talk about it in the next video.